Hello everyone, welcome to the new videos on image processing. So in the last session we have seen how we can detect the eyes of a person. Okay. Now in this sessions we are going to do one more project, that is motion detections, right? It is also one of the important projects in terms of real life applications. See, name tells you everything. Motion detection. It means like we are going to detect the motion of an object, right? An object can be anything, or humans, or animals, birds, anything, right? So now see, let's understand the logic of this motion detections, right? As you know, like what is videos? Videos is a combinations of frame, right? That is called videos. And let's suppose if I want to detect the motions of a video, how we can do? Let's suppose if I'm doing like this, it means I'm just changing my frame. This is my first frame, this is my second frame, right? So it means if we can find out the difference between two frames, we can easily find out the motions of any object, right? So this is the logic behind this one. Now applications, I already explained you, there are different kind of applications, right? You can use for security camera, in night if there is no humans, okay? And there are like right now there are there are some camera which will turn on only when if there is any movement, okay? So in that case also there is the applications, okay, right? For example, if also like for security purpose, if you want to detect the movement of any vehicles, you can use this one, right? There are lots of applications of motion detections in real life. Okay, so let's quickly jump to the coding part and let's see how we can perform these ones. So first you need to import like OpenCV model. After this, let's first read the sorry, so first you need to read capture the video with the help of video capture, and here I'm passing 1 because I'm using webcam. After this, see, outside here I'll use two frame. Let's suppose I'm giving frame 1 equal to, and then here I'll write video dot read, and then I'll read one more frame, that is frame 2 equal to video dot read, because I know to find out the moment I need to just find out the difference between these two frames, right? After this I'll just use infinite loop, and inside this loop first what I'll do, I'll just resize this one frame equal to cv2 dot resize. So as you know, like to resize, so you need to pass down the frame 1 comma, and then here you need to pass down the tuple. Let's suppose I'm taking this one, this will be my size of my frame 1, and you need to do the same steps for frame 2 as well. I'll just copy this one and control V, and just give the name of this frame is frame 2, right? See why I have applied this resize method, so that like all the pixels will be on equal size. As if you try to apply that, if you try to find out the difference between two frames, right? Maybe it will throw the error. That's why we have resized both the frames, right? After this, what I'll do, I need to find out the difference between these two frames. So let's suppose I'm taking a variable, I'm giving the name diff. Now inside this OpenCV there is a method that is absolute difference. This method will use whenever you want to find out the difference between any two frames. So here I want to frame 1 and then frame 2. Okay, so this will give you the difference between these two frames and stored in this. After this, what I'll do now, see here, for the better understanding, right? So you need to apply different concepts that you have performed earlier, right? That you need to find out the blurring of the images, you need to apply some like morphology operations, you need to apply threshold. Okay, so all of you know, like first you need to find convert this in the grayscale images. So let's suppose I'm taking cv2 dot cvt color, and then I need to apply on this diff method this images, and just call the method color underscore bgr to gray. Now first I'll need to find out the blurring, so I'll take one variable and I'll call the Gaussian blur, right? Because this Gaussian blur will give you the good quality of images. And I need to apply on this grayscale images. Kernel size here I'm taking 5,5, and sigma x no need, so I'm just keeping it to 0. After this you need threshold as well, so I'm writing threshold equal to cv2 dot threshold, and I need to apply this threshold on this blurred image, and then threshold value I'm just keeping to 20, and maximum value for threshold is it. And here I'm applying cv2 dot thres binary methods, right? This already we have done. Let me explain you again. So first we have read the value and stored in this variable video. After capturing the video, you need to here I have created two variables, frame 1 and frame 2, because we need to find out the motions. And how we are going to find out the motions? By finding the difference between two frames. And inside this infinite loop, first you need to resize the both the frames so that you can apply some mathematical operations, else it will throw the error. Okay, and this size you can keep as per your choice. And then here I have applied one absolute difference method so that it will give you the difference. And then here first you need to convert the images in grayscale so that you can easily apply these blurring thresholding applications. So first I have used Gaussian blur so that it will give you the noise free images, and then I have applied this thresholding. After this you need to apply dilations as well. So I'm taking CV2 dot dilate, and then I'll apply on this threshold image, and kernel I'm doing 0. So here I'm taking none, because, and iterations I'm just taking 3. It means I want to apply these dilations 3 times so that for the better performance. Now after this, here we have applied some basics properties, right? After this, what you need to do to detect the motions, you need to find out the contours. And as you know, like contours will give you two. One is contour, second one is hierarchy. So no need to there is no use of hierarchy, so I'll just need the contours. Why contours? Because if there is a motions, I want to draw some things, draw some contours, right? That's why here you need this one. So I'll write cv2 dot find contours. So first we need to draw the contours, draw contours. Okay, so but here before drawing, first you need to find out the contours. Sorry, so I think here you need to write down find contours, find contours. And this contour, first I'll give the images, that is dilated version of images. And there is, as you know, like there is different methods of this cv2 dot return tree. This method I'm taking, and cv2 dot, there are different methods. Let me check the methods because I forget the method. Okay, chain approx none. So chain approx none. So these, okay, after this what I need to do, so say here we have just found the contours, right? After this what I need to do, I need to find out the coordinate point so that we can draw some geometry, right? So what I'll do in on these contours, so you need to iterate over this contour. So I'll write for contour in contours. So it will give you x, y, w, h. And what I need to do, cv2 dot bounding rect, and here I'll pass contour. So what I have did basically, see here what it will do, here I'm just iterating, because in this contours I have stored all the contours, right? And now I'm iterating over this contour so that it will give you the bounding rectangles. This is the inbuilt method of this OpenCV. Okay, and because see you need to draw the some rectangle geometry. Now after this what I'll do, I need to draw some things over this one, right? So I'll take an if contour dot area. I think there is a method, I just forget the name of method. Let me check the name of method. Okay, if cv2 dot contour area, right, and I'm just passing this contour is less, let's suppose if less than 8000, so no need to do let's pass continue. So it will just skip that part and it will iterate loop from, and else cv2 dot draw rectangles, right? I want to draw the rectangle on the original images. Okay, so I think the images will be frame 1. You can draw on any images. Here I'm taking frame 1, and then point 1 will be point 1 will be x comma y. Next point will be x plus w comma y plus h, right? and next will be the thickness. After this, what we need to do, so after drawing the rectangle, I want to show this rectangle on the real images. So I'll just come out of this for loop and I'll call the ImShow method. These methods will just draw the images, and I just want to draw on the image frame 1, right? See, after this, let's suppose if I run this one, it will not work. Why? Because there are lots of frames are there in the inside a single videos. So you need to keep rotating the frame, right? Suppose right now we are working on first 2 frames. What about next frame? So what I'll do, I'll just write frame 1 equal to frame 2. It means I'll just store the frame 2 inside frame 1, and then what I'll do for this frame 2, I'll just read the value, right? So I'll take ret here I'll take frame 2 equal to, and again I'll read with the help of video dot read, right? And then here I'll write if cv2 dot wait key 1 is equal to this to stop the, okay, so I'll press, if I press q, it will like terminate the loop, and then it will just release the video and then destroy the windows. Sorry, destroy all windows. Now let's run the code and check either it's working or not. If I run, yeah, you can see, now you can see, now it's, there is no movement. Now you can see if I'm doing any movement, it is drawing some rectangles, right? Right now you can see here, if I'm doing any small movement, you can see some like geometrical shapes are there, right? And if you want, what you can do, you can just change this value. Instead of 8,000, let's suppose if I put 1,000, okay? And now if I run this one, you can see it will detect very small things also. See, in my study, it will detect a very less movement as well, right? So it's better, you can just adjust as per your choice, right? You can keep 5,000 for the better result, better performance, right? See, like this one. Okay, so I hope like all of you like understand the concepts, right? So in the next sessions, we'll do some more like project like this one, right? For now, I'm just giving you some tasks. Just try to apply, try to take some videos, downloaded videos, okay, and just apply this concept in the downloaded videos, and let's see if it is able to detect some like motions inside the downloaded videos or not, right? So this is all from these sessions. I'll see you in the next class. Bye everyone, thank you so much.